The database enforced every rule it had been given. Every constraint passed. Every check returned valid. The data was structurally correct, internally consistent, and completely wrong. This series has covered what constraints do, the rules databases enforce about what data is allowed to exist. This final video is about the boundary of that, what constraints cannot do, what the database cannot know, and what that means for the systems built on top of it. A database constraint operates on data that is already inside the system. It can verify that a value falls within a declared range. It can confirm that a referenced record exists. It can ensure that a required field is not empty. What it cannot do is reach outside its own boundary, to the physical world, to external systems, to the intentions of the person who submitted the data, or to the question of whether the data is true in any sense beyond structural validity. Think about a passport control officer at an airport. The officer checks that the passport is genuine, the document is valid, the chip reads correctly, the photograph matches the holder, the expiry date has not passed. These are structural checks. They confirm that the document is what it claims to be. What the officer cannot determine from the passport alone is whether the person intends to return to their home country, whether they will work illegally, or whether the address listed inside the cover is where they actually live. The passport is valid. The claims it cannot verify are matters of truth about the world, and the document has no mechanism for checking those. A database constraint is the passport check, rigorous, reliable, and bounded by what the document contains. In 2019, a UK property rental platform operated a listing verification system. Landlords submitted property listings with an address, a declared number of bedrooms, a monthly rent, and a set of amenity flags, parking, garden, pets allowed, and so on. The database had a comprehensive constraint set. Addresses required a valid postcode format. Bedroom counts were constrained to between 1 and 10. Rent values had a floor and ceiling. Amenity flags were boolean. Every listing that passed these checks was published to the platform. Over an 18-month period, the platform received 6,200 complaints from tenants. The complaints fell into 3 categories: properties listed as having parking that did not have parking, bedroom counts that did not match the physical property, and rent amounts that changed between listing and tenancy agreement. An internal audit found that approximately 11% of active listings contained at least one materially inaccurate field. Every one of those listings had passed every constraint in the database. The constraints had done their job precisely. They had confirmed that the data was structurally valid. They had no mechanism for confirming that the data was true. This is the fundamental boundary of constraint-based enforcement. A constraint can verify structure. It cannot verify correspondence with reality. A postcode in the correct format is not necessarily a real postcode at which the property exists. A bedroom count of 4 is a valid integer within the permitted range, whether or not the property has 4 bedrooms. A rent value of £1,800 per month passes every check, whether or not the landlord intends to honour it. There are several categories of truth that lie beyond what any database constraint can reach. The first is external factual accuracy. Whether the data corresponds to something true in the physical world. Does this address exist? Does this property have the features listed? Is this company registration number assigned to a real trading entity? These questions require external verification against authoritative data sources, through physical inspection, or through third-party validation services. The database cannot answer them. The second is intent and future behaviour. A constraint can verify that a value is present and valid. It cannot verify that the submitter intends to honour what the value represents. A contract amount, a delivery commitment, a declared purpose. These are assertions about future behaviour, and databases enforce rules about data, not promises about action. The third is semantic consistency across fields. A database can enforce that individual fields meet their constraints. It generally cannot enforce that the combination of fields makes sense in the real world. A property listing with a monthly rent of £500, a central London postcode, and 5 bedrooms is structurally valid. It is implausible. No constraint catches implausibility. Only specific structural violations. The fourth is drift over time. A listing that was accurate when submitted may become inaccurate as circumstances change. A parking space that is subsequently lost. A renovation that reduces the bedroom count. A rent that is adjusted before the tenancy begins. Constraints validate at the moment of write. They have no mechanism for monitoring whether the data remains true after it has been committed. There are 3 things that follow from this. First, design verification layers appropriate to what your constraints cannot reach. The property platform needed a verification process that operated outside the database, cross-referencing postcodes against land registry data, flagging listings with implausible rent-to-bedroom combinations for manual review, implementing a tenant feedback loop that could surface inaccuracies after publication. Constraints are the foundation. They are not the complete structure. Second, be explicit about the trust model of your data. Data that has passed structural constraints is not verified data. It is structurally valid data. Those are different claims, and conflating them produces systems that treat validated structure as a proxy for truth. The property platform's listings were internally consistent and externally unreliable. The constraint system gave no signal that distinguished one from the other. Third, understand that the limit of constraints is not a failure of database design. It is an accurate description of what databases are for. A database enforces the rules it has been given over the data it contains. The question of whether that data corresponds to reality is a product question, a process question, and an organizational question, not a schema question. The answer to it cannot be written as a check constraint. The passport control officer confirms the document. They cannot confirm the person. The database confirms the data. It cannot confirm the world the data describes. Both the officer and the database are doing precisely what they are designed to do, at precisely the boundary they are capable of operating within. The gap between structural validity and factual truth is not inside that boundary. It never has been. This series has been about the rules databases enforce, the ways those rules fail, and the conditions under which they hold. The final thing worth knowing about constraints is the one this episode has covered: what they cannot do. Not as a limitation to be worked around, as a clarity about where the database's responsibility ends and where everything else begins. A system that knows what its database can enforce and builds accordingly for everything it cannot is a system built on an accurate understanding of the tool it is using. That is where reliable data comes from.